So in question 15, we are being asked to find the maximum value. And it's a trig function, and it's 20 plus 13, the cosine of 2x plus 150, and it's in degrees. And in a way, this question is a little bit of a cheat, because there's a lot of information here that doesn't actually matter at all. And the reason I'm saying that is that when you're asked to find the maximum value, all you need to do in this question is say, okay, what is the biggest number every cosine in the world can be? What's the biggest any of them can be? Well, how high up does a cosine go, and how low down does a cosine go? Well, isn't it up to 1 and down to -1? So if you want the maximum value, this guy here, the most it can ever be is 1. So see all that 2x plus 150 degrees? Doesn't matter. Couldn't that be 22x minus 1,000,000 pi? Still doesn't matter. Anything that goes here doesn't affect this guy, because this guy, the worst case scenario is 1 and down to -1. So what we're looking at here is 20 plus 13. And so the answer would be simply 33. And 33, because evidently I like picking A's, is A. Now, if I'd asked, what's the minimum value? You would say, oh, 20 plus 13. Now, the smallest value a cosine will ever be is -1, because cosines look like this. And they go from 1 to -1. And that's for cosine x. But it's also for the cosine of anything you like, take away anything you like. Right, that might have a different period. It might be phase shifted, but it's still only going to have an amplitude of 1, right? 1 up and 1 down. So if you wanted to know what the minimum value was, it'd be 20 take away 3 to 13, and the answer would be 7. A third way of doing this question, couldn't you have plugged this into Desmos and seen how high it went? And I bet you find out the highest it got to was 33.
Thank you. I think I just forgot what maximum meant. I'm going to be honest.
Well, it's better knowing now, right? Because if you see it again, you'll say, oh yeah, I know what that one is. I forgot, but now I know.
You know, it's one of those days.
I hear you. I think I've had one of those years, so we're in the same place. Right, next question. What have we got? I'll put somebody in the spot. Sophia, in all of trig, what's the hardest thing for you to do? What's the one you find difficult to get your head wrapped around? Any topic that comes to mind?
Maybe trig equations?
Trig equations, okay, so while people are thinking equations, I'll pick a trig equation. So there are many, many different kinds of trig equations, of course. There's one, just as an example. And let's say that they have some kind of restriction up here. So when you see that, that means there's a finite number of answers, right? There might only be 2 or 3 angles. If you don't have that, then don't you have to add the 2 pi k thing, right? Which is the period with a k at the end. Now, in this particular trig equation, it's set up to be factored as a quadratic. And so what I'm looking at is 2 sine squareds, take away a sine, add a 1. Well, I know that 2 sine x times sine x will get me the 2 sine squared x. It's a bit like me trying to factor that guy. Well, I know, because I've done a lot of factoring in my life, that you get 2y and a y, and then you just do whatever combination works, and this is the one that works. And if you check it, you can FOIL it out and it works. So this is very similar. And you get that. Now, each of these factors then gets solved individually. So this one here, for instance, is only going to work when sine x is 1. And if you use your unit circle, or if you draw a little picture of what the sine x equals 1 looks like, don't you get 2 answers? One of them is at pi upon 2, and the other one is 3/2. So there's 2 answers already. And this one here, if you solve it, sine x equals -1/2. So I go to here and I find angles whose y coordinate is -1/2. And as I scan through, I get one of them here, which is 7/6 pi. And then I get another one over here at 11/6 pi. So in this particular question, there were 4 solutions, at least in the range 0 to 2 pi. If I had said this restriction, then you wouldn't have been picking everybody. In fact, you're only going to pick guys who are less than a pi, which would mean in this case, wouldn't it be just one? Yeah, it'd only be that one answer. Right. Now, if they didn't give you a restriction, wouldn't you take every single one of these answers, for instance, 7/6 pi, and add period, which is 2 pi, okay, and pi upon 2 plus 2 pi k, and 3/2 pi plus 2 pi k, and 11/6 pi plus 2 pi k. And not that it happened here, but shouldn't you also check if one of these actually has all of these inside, in which case you only need to use one of them instead of 2 separate ones. That can happen with tans, for instance. Imagine I factored one, because it could happen, and I got that as a factor. Now that would mean that sine x would have to equal 2. What would that be? What would that mean in the context of this question? Could you find angles whose sine is equal to 2? No. So that would get you, right, no solutions. Sometimes you do that, right? Sometimes you get things that can't exist, don't exist. And so those factors don't generate any solutions at all. Right. That's the guy we just did, right? Everybody had sines in it. Suppose I gave you one change, but one change can do a lot of damage. Suppose I gave you that. I cannot factor 2 different tricks, right? What would be the strategy to fix this question so that it became doable? Can you see anything here that could be changed in order to make this equation solvable?
Isn't it possible to convert the sine 2x or squared x to a cosine? Like, yeah, like that.
Exactly. Now, you need, typically, don't you need one trig in any trig equation, right? You need everything to be sines, everything to be cosines or tans, but you need everybody to be the same thing. You can't really deal with two different things, right? So if I did that, I would then have 2, take away 2 cos squared x, take away a cosine x plus a 1, and then, you know, make it look pretty. Well, not you could make this look very pretty, but you would do at least collect the numbers together and then multiply everybody by negative, which essentially just changes their sign. Now, in that case, you've now got something you could factor, and then you go ahead and, you know, solve it the same way as we did this one. So that's a little taster of one of the many different kinds of trig equations. Has someone got a question for us?
Yeah, so I found what I was going to ask you.
Good.
So we went over so many different like finding angles and finding sides, and there's so many different formulas. And like the multiple choice, like 10 through 12, it has like the different ways to do it and everything. And I was just wondering if you can go over those really quick.
Are we talking multiple choice in the
Yeah.
practice one, 10 through 12? Yeah? Just making sure that's what you're asking me, yes?
Yes. So, I'm sorry, 11 and 12.
11 and 12, okay. So, if you are given a triangle,
Oh, I'm sorry, and as well as 9. Sorry, that's the one.
well, I'll do 11 first,
Yeah.
and then I'll do 12, and then I'll take a little note to do 9. Here is, well, I'm just creating a similar question because I think that's helpful. If you're given a triangle, but you're given limited information, right? Maybe some angles, maybe some sides. What rule do you use? Because the question is, do you use sine rule? I'll write the rules down. Is this a sine rule question kind of situation? Is it a cosine rule question? Is it a SOHCAHTOA question? For example, or is it essentially impossible? In other words, you haven't given me enough information to do things. Well, let's give you an impossible one first. If I told you that was 3 and that is 4, could you find all the missing angles and sides? No, it's impossible. There's not enough information. Now, I'm going to give one more piece of information, and then you should be able to solve it. But now the question is, which method? So, if I tell you that's 100 degrees, so what do you know? You know 2 sides, and you know the size of the angle in between. If you want to find all the other missing angles and sides, at least to start with, you're going to use the cosine rule. You might say, well, why do I know it's the cosine rule rather than all the other choices? First, let's kick out SOHCAHTOA. SOHCAHTOA only works with right angle triangles. So if you see a right angle triangle, it's SOHCAHTOA. And if you don't see a right angle triangle, it's definitely not right angle to grade, then it's not SOHCAHTOA. So that one's going to be an easy one. It's a little bit trickier for the sines and the cosines because, you know, they look very similar, you know, situations. So here is the rules for the cosine. You will use the cosine rule when you know all 3 sides. You will use the cosine rule when you know 2 sides, as we have here, and the angle between those 2 sides. And you will use the sine rule the rest of the time. That's a pretty simple set of rules, right? Instructions. If you see 2 sides in an angle, it's going to be a cosine rule. Now, what would I find first then? using the cosine rule based on this piece of information that you have?
The missing side.
I will miss the missing side, which I'll call, I don't know, C, because I want to. Now, once you know that side, can't you then use the sine rule or the cosine rule, right? You've got more in, once you know what C is, right? If it's 3, right? You're good to go, right? You can do the rest. Oops. You would use the cosine rule in this situation, right? You know all 3 sides. In this case, wouldn't you use it to find angle A? Or angle B or angle C, whatever the letters are called. Now, once you know that angle, can't you then decide to use sine rules or cosine rules for everything else that's missing? And if someone gave you, so that's a cosine rule. And this one's a cosine rule. So if it's any other combination, you're going to use the sine rule. Right. That is going to be the sine rule. How do I know it's the sine rule? Because it ain't that guy and it ain't that guy, right? So if you ain't 3 sides and if you ain't 2 sides and an angle in between, whatever weird combination they give you is going to be a sine rule. But sometimes you have to, help. This right now won't work with the sine rule yet. Won't you find that angle there? Now you can use the sine rule. So can you see the sine rule could be disguised by giving you unusual combinations of angles and sides, but you could still use it. Does that help?
Yes, it does. Thank you so much.
So let me look at 9. Question 9 is a different question because they give you a triangle and you're just being asked to find the length of a side. So straight off the bat, do you see it's a right angle triangle? So I know it's SOHCAHTOA. That's what SOHCAHTOA is for, right? Right angle triangles. In this particular one, you're told this side here is X, and you're told that the tangent of angle A, which is down here, is equal to the square root of 3. Now, I know the tangent of angle A is given in SOHCAHTOA as opposite over, oops, try that again, opposite over adjacent. And from this angle's perspective, this side is called the opposite, and this side is called the adjacent, and this guy over here is called the hypotenuse. Now, if you tell me that the tangent is root 3, you're also telling me that it's root 3 over 1. And that means I can now say that the opposite is the square root of 3 and the adjacent is 1. So I have a triangle where I know 2 of the sides and I'm trying to find the third one. And doesn't that lend itself to Pythagoras? And Pythagoras says that x squared is the square root of 3 squared plus 1 squared, which is 3 plus 1, which is 4. And x is positive the square root of 4, which is 2. And I don't worry about the negative because this here is a real physical object. So positive 2 is the only one that makes sense. And the answer to that one was D. Next question. Okay, Josiah, I'm picking on you. Hopefully you've got an answer to this. Of all the trig topics or all the things that we've done, what do you find hard? Do you find difficult to get your head around?
Can you repeat that?
Yeah. What do you have trouble with in trig? That's the gist of what I asked.
So I think I have the right angles down pretty well,
All right.
but I do think there's actually quite a bit that I have to go back over and see.
Is there any topic comes to mind? I'm just picking you so I can get a topic.
Yeah, I'm checking.
Okay.
Can we go over sine waves real quick?
Thanks. Are we talking about sketching them, amplitude, period, horizontal
Yeah.
shift, all that good stuff? Okay. So imagine that you had, let's put a sine function with kind of everything that could go wrong inside it. Yeah. And suppose I would like to know the key features, amplitude, period, horizontal shift, etc. Right? Well, amplitude is easy to find. It's that number there. And it's positive. It doesn't matter if that's 3 or -3, the amplitude is 3. If you want to get the period, for a sine function at least, it's 2 pi over that guy. So in this case, pi. If you want to get the horizontal shift, it's a little bit messier. It's not this number. It's this number interacting with that number, right? So if this was just x, the horizontal shift would be plus pi upon 3. But it's 2x, and maybe it'll be 4x the next time. So the horizontal shift is this guy divided by 2, which is pi upon 6. Now, if you wanted to sketch this entire function, right, the simplest and best way would be, I think, to use Desmos. So I'm going to go over to Desmos and set this thing up. Now, the fact that it has a negative in front of it doesn't that mean you're reflecting the x-axis, but you're going to see that in the graph anyway. So there's the -3. Here is the sine. Here is 2x. Take away pi divided by 3. And I'm going to go over here and change a few bits and pieces just to make it a little bit cleaner. I'm going to do a step, and I'm going to tell it to do steps of pi upon 6. And let's see what that does. And that's pretty good. And I'm now going to do the x-axis is going to go from negative pi upon 3. It's a little bit beyond the 0, and this guy here is going to go 2 pi plus another one, 7, 6, 15, 6. There. So if you look at, there's 0 and there's 2 pi. A lot of the features that I've just given are in this picture. Can you see that the amplitude is 3, right? Up to 3, down to 3. Can you see the phase shift, the horizontal shift, I should say, of pi upon 6? Can you also, if you count, it's a bit harder to do, but you can actually get the period by counting. I would probably pick a peak like that peak, which is 11 pi, 11 twelfths, I should say, and that peak, which is 23 twelfths. And the distance from that peak to the next is what a period is, right? It's from the top of the hill to the top of the hill. And if you take 23 and subtract 11 from it, what does that get me? That gets me 12 twelfths, which is 1 pi. So all the features that we just mentioned there, the period, the horizontal shift, and the amplitude are in that picture. Now, this is not my question, but imagine there was a 2 at the front. In fact, I'm going to put that one on the second one so we can compare them. You see, all that does is move everybody up 2 units, but won't the period still be the same? And technically, the amplitude is still 3 because it moves up to 3 and down to 3, but a little bit harder to notice in that. So everything that could get there is for the most part is inside Desmos. Now, if you're doing a multiple choice question, whatever method you use, you're just going to get the answer. I don't look for working, so I don't care. But if that was in section 2, you really should be showing me all those calculations, you know, or at least the ones that had a calculation in them. So you'd be showing me these 2.
All right, yeah.
Okay. Okay. Next question.
I have a question because on the
Mhm.
midterm,
Oh,
it
right
said
down.
on the midterm it said phase shift.
Yes.
But isn't phase shift like when we learned it, you said like that the phase would be like C in like the equations, like the x plus C.
Yeah. So in this question here, the phase shift is pi upon 3. It's just that number.
Yeah.
And the horizontal shift, which is dead easy to get mistaken, was that guy.
Mhm.
So as long as you're clear that that number there is the horizontal shift, there, say I'd go and do it again. That number here is the phase shift, right?
Mhm.
But the horizontal shift is this divided by the multiple that's here, right? So they're very similar sounding and so easy that I probably bet money on it that occasionally I've probably said the word phase shift when I meant to say horizontal shift, because
Yeah, it just said
my
like
brain just remembers the word shift sometimes and it forgets what word I'm sticking in the front.
no, you're good.
And also the problem with what I just said there is that sometimes they're the same thing. In that question there, isn't the phase shift and the horizontal shift both pi over 10?
Mhm.
Which just adds to the confusion, because I may have been doing a question like that and I called it the wrong name, but it was the correct answer.
Okay. I was just checking because on this like, question that you did in the midterm, it said phase shift and then in parentheses it said horizontal shift. And I was like, those are different things, right?
They're different things, yes.
Okay.
I can't remember why I did that. I think I was wanting to do one or the other and then I forgot to rub out the other one.
Okay, sounds good.
I do remember going back and fixing anybody who gave me either of those answers. I gave it as being correct, or at least I have recollections of doing. Okay, are we getting close to, I've done what I can for you, because really your time is valuable. And just sitting it watching me is not much fun for anyone. Do we have a question? Or are we kind of done?
I just want to make sure sine and then inverse sine of like root 3 over 2 would just be root 3 over 2, right?
That question doesn't make sense to me. Say it
Right.
again.
So like the sine of the inverse sine of like anything would just be that number, right?
It has to be in the range of the domain. So it depends on which way around you do it. So yes, in general, that is true, but isn't the domain of the inverse sine negative pi upon 2 to pi upon 2. So if you got an answer that was outside that range, you have to find the guy that's the same as it inside that range.
Okay.
That doesn't make sense to me, and I know what I'm trying to say, but it's not clear. Right. Suppose I went and said to you, I want the inverse sine of root 3 upon 2. When you do the inverse sine, all your answers come from these two quadrants. And just to break rules, because there are always exceptions to every rule, if the angle's in the top, it's a positive number. If the angle's in the bottom, it's a negative one. So if someone says to you, find the inverse sine of root 3 upon 2, you would be looking for the angle whose y coordinate is root 3 upon 2. You would say the answer is pi upon 3, or if it was degrees, you'd say 60 degrees. Everybody's cool with that one. Now, if I went and said to you, give me the inverse sine of negative root 3 upon 2, the answer to that question is, you would think 300 degrees or 5/3 pi, but it is not. We write that answer like that. So the inverse sine is in the fourth quadrant, or the first, right? Negatives are in the fourth, but you don't give me these numbers. You give me the negative angle that's the same as that place. That's what makes them a little bit tricky, right? So
Okay.
that's what I was getting at. So if you do a sine of an inverse sine, right, you have to be a little bit careful about this. So if I said to you the sine of the inverse sine of root 3 upon 2, that guy gets you pi upon 3. And the sine of pi upon 3 is root 3 upon 2. Okay. Now, if I said to you the sine of the inverse sine of negative root 3 upon 2, then that is that guy. And what is the sine of this guy? Right. So these work, right? Right. They cancel out, you get the guy you started with, right? These two work. Let's do this one. If I asked you for the inverse sine of this guy, right? What angle gives you this fella? The angle that gives you this fella, if you were looking at it, you might say, what's that, 5/3 pi? So you might say inverse sine of 5/3 pi. Oh, goodness. Let's try that again. Inverse sine of the sine of 5/3 pi. That's what I was trying to get. Right, the sine of 5/3 pi is this guy. So you would be saying inverse sine of negative 3 upon 2. But the answer that pops out isn't this guy. It's negative that guy. Do you see the difference? They don't cancel out the same way. So the inverse sine of the sine of 5/3 pi is negative 1/3 pi. Why? Because when you do an inverse sine, don't all the answers have to be in this range? And 5/3 pi isn't in this range. So it might be a good idea to do what I just did here. Do it in two separate goes. Find what that guy is equal to. And then remember that when you do the inverse sine, it's these two quadrants. Great. And if it's in this quadrant, the answer is a negative angle. And if it's from this quadrant, the angle is a positive angle. So the long-winded answer to your question is, if you do a sine of an inverse sine, do you just get the number you started with? Has two answers. Yes, when they're positive, and no when they're negative.
Okay. And then tangent is, just to make sure, tangent is in first. and
Exactly
fourth.
the same.
And then cosine is first and second, right?
Yeah,
Sounds good. I'm good.
very good on that. You know, if I take over the universe, I'm going to do away with inverse sines and cosines. I'm going to just have calculators do it for us, so that we don't need to figure out that the number the calculator gives me isn't necessarily the number I want. But strangely enough, the calculator kind of does that for you. Watch this. The sine, oops, wrong way around. The in mod degrees, okay, good. Let's do the inverse sine of the sine of -60. You see, calculator does it for us. Now, what about the inverse sine of the sine of 300? By the way, isn't the sine of 300 the same thing as -60 degrees? Right? What's what the calculator calls it? See, the calculator knows how to do it. So do you see on the top one, the answers are the same, but in the one underneath, isn't the answer not the same? That's another example of this. And I think we do have reached a kind of natural point. There is no attendance for today because you've already been given attendance. So bye-bye for now. And last chance. Everybody here should know that the final is on Friday.
Yes.
And everybody here knows that it starts at 10, right?
And ends at 1, yes.
And ends at 1 plus another half hour to get all your photographs taken and you're working.
All right.
Okay.
Thank you so much.
Bye-bye, guys. I'll see you soon.